Hello everyone. So today we are going to be looking at quantum numbers. These are numbers we've seen before but didn't really know what they meant. And we're going to look at that. So it's the post that says 10-1 quantum numbers. Here's the link for the reading. Here are the practice questions. Here is my email that you can send your answers to. So let's look at what quantum numbers mean. So, quantum numbers, the very simple explanation is they describe the location of an electron in an associated atom. So they describe where an electron is, but there are a few ways that you can describe the location of an electron. It gets complicated if you think about it beyond the basic mathematics, so we're just going to look at it in that context. So an electron in an atom is going to have 4 quantum numbers to describe its state, okay? And it's basically saying the 3-dimensional position of the electrons. So the principal quantum number is actually very simple. This is the energy level occupied by the electron. So this goes into where we have the nucleus, and then we have all these circles around the nucleus getting farther and farther away from the nucleus. So each circle is an energy level. So the one closest to the nucleus is going to be energy level n equals 1. Okay, if it's in n equals 1, it is going to be closest to the nucleus. Okay, and as you get to n equals 2, n equals 3, so on and so forth, you get a little farther away from the nucleus. Angular momentum. This is L. Okay? This describes the general shape or region an electron occupies. So it describes the orbital shape, the shape of the orbital. And we'll be getting into the different orbital shapes later on. So the value of n, or L, sorry, is going to depend on the value of n. Okay? So the angular momentum quantum number of L can have positive values of 0 to n minus 1. Okay, so if n equals 2, L can be 0, or L can be n minus 1, which 2 minus 1 equals 1. Magnetic quantum number. Okay, the magnetic quantum number describes the orbital orientation in space. All right, so electrons are going to be in one of 3 planes in 3-dimensional space around a nucleus. So you have the x-axis that is horizontal, you have the y-axis that is vertical, and you have the z-axis that is horizontal in a different direction. All right, this is 3-dimensional space. You have the x, y, and z axes. For a given value of the angular momentum quantum number L, there can be 2L plus 1 values for M. Okay, so if n equals 2, we already looked at how L can be 0 or 1. So if L equals 0, then M equals M equals 0, or for L equals 1, M can be -1, 0, or +1. Okay? This seems a little confuzzling. So, L equaling 1. So if L equals 0, there can be 2L plus 1 values. All right? So if L equals 0, we have 2 times 0, which is 0, plus 1, which is 1. So m is only going to have one value, which is 0. If we have L equals 1, we have 2 times 1, which is 2, plus 1, which gives us 3. 3 values that m can be. So these can be -1, 0, or +1. And it all really has to do with its position on the axes. All right. So lastly, we have spin quantum number. Okay, m sub s. So the spin number describes the spin for a given electron. So it can either spin in the positive direction or it can spin in the negative direction. An electron cannot have 0 spin because it's always going to be orbiting the nucleus. So spin, the way we're going to represent this, we're going to have an up arrow or a down arrow. All right. A single orbital is going to be able to hold 2 electrons, which we talked about earlier. Each is going to have an opposite spin. So if one has the positive spin, the other has the negative spin. So I don't really want you to think too hard about this beyond the mathematics, because if you get into all the physics and everything of it, it gets a little too complicated. So make sure you finish your questions and turn your answers into me.